Let's go through the code 964. List operators to trace the number. For this question, it gives us a positive integer x. We want to write operations of x, up x and up to up 3x, where we can use add, minus, multiple by or divide as ops, and to retrieve target. So we want to use the minimal number of operators, or we say minimal number of x to retrieve target. We'll see the count of x is actually the count of operator plus one, right? So we want to return the minimal count of operators to retrieve target, return the counts. So for example, if x equals 3, target equals 19, right? We can have 3 multiplied by 3, plus 3 multiplied by 3, plus 3 divided by 3, right? So we have 1, 2, 3, 4, 5, 5 operators here. So the minimum is 5. Well, see, this number is 2 to the power 8, right? So we know if we do, for this question, we should do some efficient way. Should for this to have the our x to get to target close to as close as to target as soon as possible, as fast as possible, right? First thing is that the target is always achievable because we have a divided sign, right? So we'll say if x divided by x or equals 1, right? So we can at least have use target once, right? Target times once, 1. And well, at least will be 2 multiplied by target minus 1, right? Times. So as long as we just add a target times once. So this is the first thing we observe, that we always have a solution. The second is that if this target is a big number, what we want is that we want to have x close as close to target as fast as we can, right? So we know for those kind of minus divide sign, it will get the number smaller. Um, it's not efficient, right? And also, what's the plus sign and multiple sign, right? So, we'll say the plus is actually because x is greater or equal to 2, right? So we'll see multiple sign is actually more efficient. Or we'll say at least not worse than plus, right? So what we want is that we want to have x close as um, close to target as fast as we want. So what we think about is that we have x multiplied by x multiplied by x, right? So we have the power to do the power operations for x, trying to see whether it will achieve target. If, for example, x power 10 equals target, then we just return if we already equals, right? So we don't need to do anything. We just need to return this counts. Otherwise, we are going to have, for example, we have x power count minus 1, right? Which is smaller than target. And we have x power count is greater equal to target, right? Then we have two candidates. For example, let's call the first number is p. So we are going to have two candidate. One is P, another uh is 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 Q, right? So what we need is that we just want uh to calculate. We have two because we have two candidates. Calculate those kind of, for example, this is a function, right? So uh, the least, let's call it L. So the target will be target minus T, right? And because we have a count and we have a add sign, right? Should have plus count. So this will be our candidate. Another is this one X will be Q minus target, right? And this is count. And we should also have a minus sign, should be count minus plus one, right? So what we want is get a minimum of these two, right? For these two candidates, there is another thing is that um, there are two special corner cases, right? One corner case is if this count equals zero, right? That means X is greater than target, right? So in this case, um, this one, this one, we'll see this P is actually minus one, right? Minus it's P is let's set P equals one. So if it is minus one, then we need to add an X divided by two, right? So should plus two, always plus two when we decrease by one, right? So this is one of the corner cases. Always say if X is smaller than greater than target, on smaller part, the candidate is 2 multiplied by target minus 1, right? This is C1. And another common case is that if for example, target, if Q minus target is greater than target, right? So for this kind of case, we'll see we get this kind of target is not converge. It's not it will get our case worse. So for this kind of case, right, our C2 we should ignore. Always set as integer max, right? So after we consider these two corner cases, we can write code. And because the the difference is get shrinking, right? Get smaller, and we are always trying to use the power operations as what we as many as we can, right? So so we'll see. We can use memorization for the use a hash map to memorize the key and the values. Because if this target is already calculated, we just check the memo. Then let's write code for this. Okay. So we'll say we're going to have map integer as memo equals new hash map. Okay. So what we need is return DFS X target memo. Okay. Target into DFS. So we have int X int target map integer memo. So the exit condition is if target equals X, right? Then we return 0. And we'll say if target equals 1, then return 1, right? But if target equals 1 and in the same time x equals x should return 0, right? But so that we need to have the line 7, this condition should write first, right? Because target we cannot put the line 10 as a first condition, right? Because target equals 10, it's possible target equals 1, it's possible at the same time x equals 1, right? But if we place this first, uh, if target equals x equals 1, we'll always return 0. So we'll say if memo contains p target, just return memo get target, right? So we are going to use a count variable here, and we are going to have a long p equals 1L, right? So as we mentioned, we can have a q equals x, right? But let's save the variables, just use p here. So what we will write is while p multiplied by x is smaller than target. This is why this q, right? The greater candidate is smaller than target. We're going to have p multiplied by x. And we'll have a count should increase by 1, right? So after we jumping out of the while loop, the what is q is p multiplied by x, right? Is greater equal than target. So this means how many times our operators we want we want this q to achieve q, right? So this will be the times. So what we have, so that we have two candidates. One is C1, right? Let's set this one as integer dot max dot value. So C1 will be the greater candidate, it's the Q1, okay? So we'll say, first thing is that if P multiplied by X minus target is smaller than target, in this case, we are going to consider the Q candidate, right? So we'll say Q equals P multiplied by X. So only only when it is shrinking, right? Otherwise, it is meaningless. We get the target greater and greater. So we'll say C1 will be here. There is two conditions that one is the Q happen to equals target, right? In this case, we just need to return count. Otherwise, we just need to return X and int P that is Q, right? Well, always Q minus target. And we should have a count because the count is achieve Q, right? And also we need to have minus sign, right? Minus sign. That is minus this kind of DFS, right? So we'll say first P candidate, smaller one. That is, if the zero also we consider this corner case. If this is zero, right? So that will be 2 multiplied by target minus 1, right? Otherwise, it will just DFS x int target minus p memo plus, right? So let's say result equals, we're going to have a new variable int result equals mass dot mean C1 and C2. In the memo, put target result, return result, right? If not if. We should DFS DFS, this one should have memo, right? So so we'll see, because we are always trying to do the power, right? Power operators as our highest operations. Then for it to go, so so that we'll see the power will be the majority calculations for our code. So we'll see this time complexity. It is a log xt, right? So that will be a log operation, time complexity. We can also write a Python code for this. We are going to have memo equals dictionary and return themselves that DFS x target memo. Okay, so we're going to define DFS self and x it is int and the target is int memo is dict. It's going to return int. Okay. So I'll say if a target equals x, return 0. If a target equals 1, right, return 1. If a target in memo, return memo target. Okay, so we'll have a count equals to 0. Let's have count and p, right, equals 0 and 1. So we'll say while p multiplied by x is smaller than target, then we'll have p multiplied by x and the count should plus equal to 1, right? So then we have two candidates. One is, let's say 1 equals float INF. Okay. So I say if p multiplied by x minus target is smaller than target, only get shrinking, then we'll consider there are two cases. If P multiplied by X equals target, then count one equals count. Else we have count one equals self.dfs X and P multiplied by X minus target num plus count plus one, right? And here we have C2. So there are also two cases. That is, if count equals 0, right? We'll have C2 equals 2 multiplied by target plus 1, right? Else, okay, have C2 equals self.dfs X target minus P memo plus count. So we're going to memo have results equals mean C1, C2, and we're going to have memo target equals result and the return result, right? There are some it's not correct. This is not a plus one, should minus one. Okay, sorry. Use this case.